So my research group's primary focus is to expand the synthetic toolkit towards new nanomaterials with structural precision. We are trying to control the size, shape, and architecture of advanced nanomaterials. I'm Sara Skrabalak, and my research group works in the area of nanoscience and nanotechnology. I think people recognize that we provide reliable routes to high-quality nanomaterials and, more fundamentally, a way to think about the synthesis of nanomaterials. So this is not a new phenomenon. In fact, artists have been using this property of metal nanoparticles for centuries in their stained glass windows. But of course, they didn't know that that's what they were doing, and now scientists are trying to engineer specific optical properties into their nanomaterials through unique chemistry. Well, I have a wonderful group of students. They're incredibly smart, they're hardworking, they're innovative and creative. They're just a lot of fun to work with. I have an excellent team of undergraduates, graduate students, and postdocs, and they really work well together and collaborate. People are interested in the nanoscale because interesting and new properties emerge. So we use a number of methods to make new nanomaterials. Some of these methods are solution-based, where we are trying to control the rate at which materials add to existing structures in solution. And this is very similar to the growth of snowflakes, where water is condensing onto seeds in the atmosphere. We also use aerosol methods as a continuous route to make large quantities of nanomaterials. We also use a lot of electron microscopy to study our materials. It tells us what the size and shape and architecture of all of our materials are. We are especially interested in the development of nanomaterials for chemical sensing, and this will allow us to detect different molecules and develop a colorimetric platform for disease diagnosis and detection. We are also really interested in understanding how light interacts with nanomaterials of specific shape for solar energy applications. I've often heard this complaint that nanoscience is a black box where you'll take different reagents and throw them together and hope that something interesting happens. But my research group is really trying to provide the design criteria to achieve the nanostructures that you want for a specific application. We're really trying to shine light on that black box.